So you're sitting in your math class and you have to use what we call the slope formula to find the slope. And you have this nice formula written there, m equals a bunch of y's and x's, and you got to use it. But what if we didn't need to use it? What if we could still find slope, but we can get around using that formula? Because what if it's more important understanding that slope is just meaning the average rate of change? How much does it change in the y direction compared to the x direction? And we even change the symbols, because instead of writing this m, we'll put a little delta. And the delta means the change in slope. So what if we just said the change in y over the change in x? So delta y over delta x. And you've seen this before, because when you were first introduced to slope, you said rise over run. And we think about that, where the rise is how much it goes up or down in the y direction. Y is vertical. The x, how much it changes, is how much it moves left to right. How much did it move horizontally? So instead of using this formula when looking at these points here, what if we just said, okay, how much did we go up from one point to the other? And we can count. We went up 8, and we went over 11. So now the slope of this line, the change in y compared to the change in x, is 8 over 11. Well, let's keep going. What if we looked at, we have points now, and maybe this is one you see commonly in class, and now they're actually even labeled. We'll label these points here. We have 1, 1, and the other one is 11, 7. And their 2 points are there, and you need to find the slope. We don't need to use that formula, because if we know the change in y over the change in x, that's really all slope is. What is that average amount it changes in that line? So I went from a 1 to a 7. So it went up 6 over that time. I went from a 1 to an 11. It went over 10 in that time. But it's a fraction. We can reduce that. So that's actually 3/5. So we went up 3 for every 5 we went to the right. Well, let's test that. If I go up 3 and 5 to the right, I hit the same point on the line. If I do it again, up 3 and 5 to the right, I hit it there too. So I could even take a step there and hit those new spots. So really, 6/10 and 3/5 would be the same slope, and I could use those same slopes to help me find the next points. Now, what if we had a general case? What if we didn't know the points, like the one on the top right here? They're just 2 points here. They can be anywhere in the graph, anywhere relative to the x and y axis. If we can just think, what is the change in y over the change in x, we can get away from slope formula. So, how much did we go up? Remember to count the boxes. We went up 6. We went 3 to the right, so that's 6/3, or 2 over 1. So I went up 2 for every 1 I went to the right. We come down here. We went down 3. Now we have to pay attention. We do down 3, that's a -3 direction, and we went over 9. So my change in y over my change in x is -3 over 9. Or for every 1 I went down, I went 3 to the right. So now we look at our last one. We go down, this one is really steep, we go down 5 over 1. So my change in y over my change in x is -5 over 1, or I go down 5 for every 1 I go to the right. But let's look at it a little bit differently now. What if we didn't even look at the graph? What if we didn't even draw that out and we just looked at the coordinates? Because change in y over change in x stays the same. That is that relationship we're looking for. So I went from 5 to 1. What does the number change? How much does it change to go from 5 to 1? Well, I went down 4. I went from 1 to 6 for my x value. That means it increased 5. So my slope there is -4/5, which we could check. We go down 4 and 5 to the right. So we could even take that and not even have to graph it if we have that good understanding that slope is the change in y over the change in x. Because if I look at x and y, when I just write two coordinates, 4/7 and 5/14, 7 to 14, it increased 7. 4 to 5, it increased 1. I could say that my slope is 7 over 1, or just 7. We come down to the next one. We have x and y again. I went from 6 to -2. So my change in y was -8 because it got 8 smaller. My change in x, I went from -2 to 3, increased 5, so my slope is -8/5. So by having that understanding that slope is just an average rate of change, that you're looking at the change in y to the change in x, you can count the number of blocks or the number of units that it changes on the graph, or you can look at how much the numbers change within the coordinates to find that relationship. Hope this answered any questions you have. If you have another question, go to my website, submit a question, and maybe I can make a video from yours.